Thank you for your kind introduction and for having me and inviting me to organize and convene this panel, which I think it's very timely and very relevant. And of course, it's a pleasure and honor to work with you. So ladies and gentlemen, good morning, good afternoon, dear distinguished panelists. Thank you so much for accepting the invitation to share your wisdom and experiences with us today. Let me start by a little story, which I think very nicely describes the idea which we would like to convene today. So maybe 10 years ago, there was an article in the magazine The Economist, where a lot of big multinational companies have been asking, how is that possible that the big collaborations at CERN, having more than 4,000 scientists and engineers working together for more than 20 years, on designing and building huge experiments, which have components sometimes built in other countries, and they still come together and fit with the precision, which is less than a thickness of a human hair. How is that possible? And the scientists revealed their secret, which was the shared passion for the noble values, in this case, knowledge, and also that they have the common goal, which was drawing the collaboration together. So I think this is very beautiful philosophy, and you might think, okay, maybe too ideal even for our world today, where we are facing all the problems and the global challenges. Of course, in the last year, pandemic was added to already existing 17 Sustainable Development Goals. But this has accelerated the recognition and understanding that things must be done differently. And remember the famous quote from Einstein that problems cannot be solved with the same mindset that created them. So of course, it makes a lot of sense that everybody tries to innovate today. We want to innovate education, technologies, policies. However, I think that when innovating, before trying to find completely new approaches and new solutions for the problems, it is wise to have a look of what has proven to have worked well in the past, and maybe to observe and analyze that model and approach to see whether and how it could be adapted and used for the new problem. And this is exactly what our panel is going to be about. So we are going to present to you the so-called CERN model of science policy, which is based on international, global, peaceful collaboration for common goals. And not only that it has proven to work well for almost 70 years now, but also it has been successfully reproduced and modeled by other organizations which have been set up based on that. So we will hear great examples and stories on how the way scientists work together helped to create the oasis of peace in the war-troubled regions like Middle East or Balkan, and also how CERN model was used in the field like astronomy. And let me tell you that the power of CERN spirit for cooperation and peace building has been proven in history for several times. So I just give you one very good example that once the negotiations between Soviet Union and USA during the disarmament summit in Geneva back in 1985 have been for some reason deadlocked. So the situation have been released by the informal dinner at CERN organized by the former Director General of CERN between Russian and American science advisors. And the name of this Director General is Herwig Schopper, and he's one of the big science diplomacy ambassadors, and he's also initiator of both SESAMI and SAIST projects, about which we are going to hear now from our panelists in a few minutes. But let me now introduce you our panelists. So we have very interesting and balanced panel, two amazing women leaders and two gentlemen distinguished professors. And it is my pleasure to introduce to you our first panelist, which is Dr. Archana Sharma, who is a great example of this CERN spirit, where we have more than 110 countries working together without discrimination, regardless of religious or political views, because she is an Indian scientist who has been leading the group, including Pakistani researchers, what may be hardly possible elsewhere than at CERN. Dr. Sharma is a CERN Senior Advisor for Relations with International Organizations. She's a Principal Staff Scientist at CERN, Chair of CERN's Task Force for greenhouse gas policy and many other committees. And over the last 15 years, she was also very actively participating in several initiatives for promotion of science and technology in her country, India. So dear Archana, welcome, and please tell us about CERN's history, governance, and explain to us what do we mean when we say CERN model.
Thank you very much, Barbara, and thank you very much for this invitation to be among such august people who have great experiences as well. So what I bring on the table is something very different, I would say, from the experiences of people here. I heard a bit of the previous panel that was going on, and it's very, very interesting, of course. And of course, I have been at CERN for 33 years now, a little more than I would like to admit. But it has been an amazing journey, not only to learn about science, technology, being internationally networked and really leverage this connection of science, diplomacy as well, because like you rightly said, we are working passionately towards a single goal that is driven by scientific curiosity. And we set aside all our political differences and any other differences that you might imagine. So if you permit me, I've got a couple of slides, if I could share them, and I will try to keep within my time. So yes, like Barbara said, I'm sorry, something happened. Yeah. Can you see my screen?
Yes. Yes.
Okay, good, thank you. So yes, CERN is the largest laboratory of particle physics on the planet, where we are looking for secrets of how the universe is made, which are the fundamental blocks, and how it actually works. And this is done with a range of unique experimental facilities, which are accessible to a worldwide community. So that openness and transparency of what we do here at CERN is extremely important in bringing together people from various backgrounds, various corners of the globe. And here I might want to say that if you look at this picture in front of you, the satellite picture of the region here in Geneva, you see on the right-hand side, you have Lake Geneva, and on the left-hand side, you could just about see the Jura Mountains. What it says is that, we are straddling two countries here and sharing resources, sharing real estate, sharing, of course, all the manpower and everything that comes along with it. But importantly, the 7 kilometers go cross the border, 11,000 times per second. So this is a unique feeling to imagine that, you're straddling countries and you are working across borders. And in this context of science diplomacy at CERN, this is a very early example of institutionalized scientific international cooperation. Yes, so CERN was was founded in 1954, just after Europe was ravaged by the Second World War. And scientists came together to work towards this common goal of searching for knowledge, and started with 12 European member states, as is mentioned here. And right now we've got 23 member states from Europe, and it's also a proto-European collaboration and proto-European diplomacy towards scientific agreements and sharing scientific knowledge as well. In addition, scientific governance. So that, of course, leads to all the decision-making that happens, particularly for policies and of course, funding agencies and so on. As you see on this slide, the distribution of CERN users is all over the world by now. From member states, it's about 6,500. And from the other countries, it's non-negligible. It's nearly 1,300 that come from other countries. So the geographical and cultural diversity is also one of the strengths that builds, that lends itself to build the case that would work at CERN. And I would like to point out that there's a good fraction of women as well in our workforce. So CERN, while doing the good science, of course, we have been receiving Nobel Prizes. I proudly say we, but I am one upon 15,000 people. And here you see that you may have heard about the Higgs boson that was discovered in 2012. That was discovered in 2012, and after which the Nobel Prize was given to Professor Peter Higgs and Francois Englert. So the Swedish Academy at that point described CERN as probably the largest and the most complex machine ever constructed by humans. And it is indeed a technological marvel and a feat that has been performed, like Barbora said, coming with pieces coming from all over the world and fitting to the, less than 10 microns pretty much. So this kind of cooperation where we can research, we can innovate, we can discover, share, and publish. We can agree, first of all. That's the bigger thing, that we can agree together to publish and then transfer this knowledge off to the society and bring the world together with this intercultural dialogue that we continuously have been having over the 3 decades that I have seen at CERN, and of course we have in the audience also here. So yes, CERN is committed absolutely to the United Nations Agenda 2030 for Sustainable Development, and this can happen. First of all, I might want to highlight the WWW that was invented at CERN. It was for sharing of scientific knowledge, and imagine what has happened to it in 3 decades. Today, it's nearly a human right for a person to be connected. And it is now entrenched into every aspect of global governance, whether it's a vaccine, whether it's the pandemic management, whether it's information, whether it's finance or the economy itself. So trillions of dollars are going through the internet with just a click of a mouse, and it was given for free to the world. So there is one impact that we cannot neglect. However, it's a past laurel, so now we have to look at the future, and for that we have to leverage innovative technologies, which will then help us and help the nations, help the society, and the whole world, in fact, towards sustainable development and towards attaining the agenda for SDGs, of course. And for that, obviously, we look to science diplomacy. We look to the model on how we have been building towards a unique set of goals, and we agree on a conduct which then lends itself to a distinct governance structure. There are several examples that have been mentioned earlier. And of course, CERN gives a culture that then permeates and percolates to the scientists, to the students, and to the technicians in addition, down the chain, up the chain, along the chain, everywhere. The challenges are very common in various countries, and particularly in the low-income countries. There, we need to come together and to look at how scientific knowledge can foster this dialogue. And we can definitely leave aside the politics and try to see how evidence-driven data management, data governance, and also technology management can help in science diplomacy towards our common goals. Thank you for your time.
Thank you very much, Archana. This was very interesting. So as a CERN model serves as a blueprint for a global peaceful collaboration, several multinational research facilities in other fields have been also built following its example. And one of them is Sesame. And our next panelist, Professor Sir Chris Lelewellyn Smith, will tell us more about it in a while. But first, let me introduce him. I'm really delighted to have him here with us today, because somehow I've realized that it's funny that whatever I found extremely relevant to do in my career, Professor Lelewellyn Smith was a leading figure there. If it was thermonuclear fusion or CERN and particle physics, sustainable energy, science diplomacy, science outreach, he's a top person on many physics fields, and he can share with us a lot of wisdom. He's a former Director General of CERN, of UK's fusion program, former chairman of ITER Council, and former president of Sesame Council. And he has been also advising nationally, internationally on science funding, collaboration, energy issues, including UK's Prime Minister, and he even received the award for science diplomacy. So, Chris, we are looking forward to hear more about Sesame, please.
Thank you very much. I want to share my slides, but they seem to have vanished. So let me see, can I find them? I'm not sure what's happened to them. They were on my desktop. I'm going to have to use the unofficial version, not the version that's been put with the UNESCO or the United Nations branding. So too bad. I'm sorry about that. So Sesame, obviously the word sesame suggests opening doors, and that's very deliberate. But it's also an acronym, stands for Synchrotron Light for Experimental Science and Applications in the Middle East. That's exactly what it is. It's a third-generation light source located near Amman in Jordan. And light sources are effectively extremely bright sources of light coupled to very large microscope, which make it possible to study matter on scales from atoms to viruses with applications in physics, chemistry, biology, material science, medicine, archaeology. Now, Sesame was conceived in the late 1990s with exactly the same aims as CERN, which was conceived in the late 1940s, in fact. First, to enable construction of a facility beyond the means of individual members. And secondly, to foster cooperation between people. Now, in the case of CERN in the late 1940s, those were people who'd recently been in conflict. In the case of Sesame, these are between people, some of whom actually are in conflict today. And the members of Sesame are a rather remarkable group: Cyprus, Egypt, Iran, Israel, Jordan, Pakistan, Palestine, and Turkey. Let me give you an example of how science can bring people together and to help bring bridges. I have a Pakistani colleague who works at CERN in one of the big collaborations who wanted to take a group of technicians to Geneva to work on the experiment. And his technicians did a bit of homework and they realized that one of the other members of the collaboration was Israel. And they said to him, "We can't work with Israelis. These people are devils. We can't work with them." And their boss said, "I'm sorry, you're coming to Geneva." And a few weeks later, they came back to him and said, "You know, those Israeli guys, they're pretty good technicians, and actually, they're quite nice guys." So science, by giving people, you can develop respect for people in a field like science. And this, when you can respect their science, you may start respecting or tolerating at least their views in other fields. And that's one of the aims of Sesame. Now, Sesame is, of course, nothing like on the scale of CERN. This is the building here. Why build such a thing in the Middle East? There are many other light sources elsewhere. First of all, to build capacity in the region. The broad programs, which I've listed here, make synchrotron light sources absolutely ideal for scientific capacity building. Secondly, international collaboration is the obvious way for countries with relatively small scientific communities or limited science budgets to build a synchrotron light source. And finally, as I've said, to bring people together. Sesame, like CERN, is a user facility. The people there's not a brain drain from Cairo or wherever, Tehran, that people move to Jordan, to Sesame. They come there, spend a week or two doing experiments and go home again. And they stay in the guest house, which you can see here. And then they meet over coffee, over breakfast, and they talk to each other. So it builds understanding between peoples here, some of whom would never normally meet each other. Now,
Chris, we cannot see your slides. I'm sorry to interrupt.
You can't see them at all?
No.
Well, then I must be talking nonsense because they mean nothing without the slides.
Oh, no, I understand a bit of it. Maybe the other.
Let me see. Let me get out of here, escape, get back into screen sharing and see if it works this time. You should have said that to me earlier.
I'm waiting for them to appear.
I'm waiting for them to appear. Here we go.
Okay, let's.
All right, now you've got them.
Yes.
Okay.
Yes, that's fine. Thank you, Chris. Sorry to.
Right. So this is the slide I've just spoken to about the reasons for Sesame, what it is. Here's the building, and so on. So now let me go to the second slide. I'm sorry that must have been somewhat opaque to those who could not see the slide, all of you. I have been the president of the CERN Council, the Sesame Council, for nearly 10 years. I took over from Herwig Schopper, who actually, you're not correct, Barbara, he was not the initiator of Sesame, though he played a vital role in its history. When I took over, we had a building, I've just shown you a picture of it, but there absolutely no funds or plans of how to build the storage ring. When I handed over, the storage ring was working and it was opened by the King in May 2017. During its very long adolescence, since when it was conceived in the 1990s to when it started to do science a little bit after 2017, there was an extensive training program which built capacity in the region. This was funded by the generosity of various governments, organizations around the world, by various scientific societies, and by the various laboratories who opened their doors to let people come in to be trained. Sesame has faced many challenges. They've mainly been financial, not political. I will talk about the political challenges later. There were some political challenges, but it is now working. And despite the financial difficulties, only with 3 are what called beamlines, there will soon be 5 and later 6, thanks to many people, particularly the EU, to CERN, to UNESCO, the Italian government, far too many for me to read. And it is producing scientific papers and it is bringing people together. Another remarkable thing about Sesame, it's run on a shoestring. The budget is nominally less than $5 million a year. The staff is about 50 people, but in fact the budget's less than that because many of the countries find that they can't pay. And it was clear to me, it became clear about 6 years ago, we'll never be able to run it because these devices use a lot of power. And the paying for the power will double the budget and bring the project to a halt. But we persuaded Jordan to allocate some EU funding to build a solar power plant. Sesame is the only lab in the world powered entirely by renewable energy. It's a real world first. It doesn't mean it can only work when the sun's shining. The Jordanians give us the same amount of power we give them, but at the times we want it and we give it to them when we can do it. Now, what are the lessons from Sesame? And I'll come back to these later. First of all, the people of goodwill with common goals can collaborate across some of the deepest divides on the planet between Israel, Iran, Palestine, and so on. It's really remarkable. The negative lessons are that these are countries that are not used to being involved in science. They find it very, very difficult to pay, although the contributions are very small. It's been difficult to attract members. We try to get new members. We get countries very excited, but when they see the list of members, for one reason or another, they say it's difficult for us to join such an organization. I hope that's going to change now that Sesame is working so people can see really the benefits and there is some easing of tensions in the Middle East. The final thing I've learned is the governments we talk to pay lip service to building scientific collaboration. But when it comes to it, they don't really see that as a goal. So for example, let's take the United States. Obama made a famous speech in Cairo, I think it was in 2010, in which he said we should be building scientific capacity in the Muslim world. So we went to Washington and said, right, Obama said this, EU's helping, other countries in Europe are helping, how about it? And the thing, it didn't happen. It just couldn't happen. The State Department said, we don't really support science, go to the Department of Energy. Department of Energy said, our goals are scientific, not diplomatic. So it's quite difficult in practice to get countries to support these things, but some have done it, and Sesame is working. Sesame has been a triumph of optimism over skepticism. There are various, getting it built was very difficult. There are various times when rational people would have given up, but we kept going. It is producing scientific papers, and it is today working and bringing people together. Thank you very much, and I'm sorry about the slides.
Sorry, I had to unmute. I apologize for the slides. I was trying to say something, but I realized that I was muted for some reason. So, but we could understand very well. So, thank you very much, Chris. I am now very happy to welcome and introduce our next panelist, You know, when I publish articles on connecting science with society in the scientific community, I'm trying to encourage my scientific colleagues to become more active in science diplomacy. And I am highlighting the shining example of Dr. Sanja Damjanovic, who is the scientist active in CERN and also in German laboratory GSI, and who became a science minister of Montenegro. And she also acted as a first chair of Intergovernmental CEIST Steering Committee. And it was thanks to her hard work that the international project in Balkan, CEIST, or Southeast European International Institute for Sustainable Technologies, received the first official political support by the government of Montenegro in 2017. And then she spent 4 years of her mandate to build up this CERN spin-off and the great example of science diplomacy. So glad to have you here, Sanja, and if you are curious to hear more about CEIST.
So thank you very much, Barbara, for your nice introduction. Good afternoon or good morning, good evening to everybody. I need to say that science diplomacy is now really in my heart. And I really thank for the opportunity to present you yet another concrete example of science diplomacy, so-called CEIST project. For all of you, CERN, Sesame is something which you know, but most probably of you don't know about the CEIST, which is research infrastructure, which is coming on the horizon. I think we all learn now from the previous two speakers that science diplomacy is really powerful instrument which can work when other kinds of politics or diplomacy have failed. But indeed, we also see if we want to really make a science diplomacy efficient, we need to create a place for scientists to meet and do research together, even those who would never ever sit around at the same table together. And here, what we all now can see and learn that research infrastructures are the assets for science diplomacy. They are proven to have a powerful socioeconomical impact as a multinational venture. So after CERN and Sesame, I'm really happy that now we have another third example of research infrastructure with the mission of science diplomacy coming up. Now you may ask why CEIST, why research infrastructure for Southeast Europe? Now, if you look at the Southeast Europe, this is a large integral part of Europe with 40 million inhabitants, but it needs help to develop sustainable economy and social cohesion. Now you can ask why. Now, unfortunately, due to recent history, war, civil war in 1990s, actually war from 1991 to 2000, disintegration of former Yugoslavia, all scientific, economic activities very much slowed down, and presently we see a large gap between this part of Europe and the rest of the Europe. As a consequence, this region suffers ever since from strong brain drain. We are permanently losing our best talents, and this is, I would say, our largest economic loss. I would like also to remind you, because people very often forget, that this region of Southeast Europe in the past had incredible, nice period of technological development. I would like to remind you that Yugoslavia was one of the founders of CERN in 1954, for example, when Austria was not a founder. I want to give you another example that the first research nuclear reactor was established in this region in 1959, just 2 years later than the first research nuclear reactor was established in Germany. And not only that, we had 3 research institutes older than CERN. But now the question, how to recover tradition which we have, how to slow down brain drain or even to revert it, or how to mitigate the still existing tension between the countries. The best way is actually to establish large-scale research infrastructure based on the newest technology with the mission of science for peace. Another objective of our CEIST, and this is a need, is to build international cooperation and scientific capacity in our region. And I'm proud to tell you that even now, after a very short time, we have support of 18 renowned research centers from Western Europe and clinics. I will remind you why clinics in a moment, and helping us exactly to build the capacity in our region. And third important mission of our project is science for society. Why? Because our CEST actually is research infrastructure for cancer therapy and biomedical research with heavy ions, which today present the most modern and powerful method to treat cancer. Just to tell you, there are only 12 research infrastructure of this type in the world, and only 4 in Europe. Now I show you here the map of our sea region. As I mentioned, 40 million inhabitants, and here are the 10 potential members of this project. Now, I give you some kind of political milestones. At the end of 2016, I became Minister of Science of Montenegro. I was put in contact by my mentor, Professor Hans Specht from Heidelberg, former director of GSI, with Herwig Schopper, who propagated exactly idea, why not establishing some research infrastructure in the region of Southeast Europe. So it took me 3 months to convince the government of Montenegro to officially support this initiative. And not only that, only a few months later, this project got flag of regional project. And look what happened. There was a signature or declaration of intent on the CERN ground by 10 ministers from our region. And you know, at CERN, politicians are coming every day, but this event was very special because at the same time, you had 10 ministers on the CERN ground. And also a few years later, that was put on the higher political level with Prime Minister signing a memorandum of cooperation. But it was also nice because we were working always not only top down, but also bottom up approach. And we made so many events where we connected diplomats, politicians and scientists, and we built up the trust from European Commission. We built support from European Commission. I need to really enhance the role of the former Commissioner Carlos Moedas, and we got the first financial support to start the second phase, development phase of the project. We were also after that very much successful to absorb we show the capacity. You see, we absorb money from very competitive Horizon 2020 call. So we are now we are assuring design phase of the project. But not only that, CEST even now became part of economic investment plan for Western Balkan, where only hard infrastructures are in. And now CEST is the only research infrastructure in this economic plan, where they are appointed at this moment 9 billion euros. I mentioned that we got support of renowned institutes, and here I need to emphasize the role of CERN, which offer to host development of the new generation of medical accelerator design. So we are not going to be repetition of existing machines. We are making breakthrough in technology. And also from GSI side, we got very much support for enhancing biomedical research and preclinical clinical research. I just want to remind you that at the research infrastructure, GSI's first 440 patients in Europe were treated with this most modern method. More recently, I'm also happy to share with you that we got also official support from the Swiss government and directly from the Federal Chancellor, Mr. Ignazio Cassis, and Switzerland is going to offer us support to develop a science diplomacy roadmap, because in front of us are very hard decisions like one of the site. Last but not least, we also got support of Atomic Energy Agency to build up a capacity, which the same would happen also with the CESNI. So I was maybe fast in speaking, excited like always when I talk about this project, but I'll show you the timeline of our project. It's a long-term project, and we already finished the first phase. We have a concept study. We started design phase. We are in the best hands. We will get the beautiful design. We apply for S3 roadmap as a first time project from this region. Actually, this region for 60 years, there was any new infrastructure built. So we have, for the first time, applied for S3 roadmap. We expect site selection by end of 2022. If everything goes well, and we hope, we will start construction of the facility in 2023. And if our dream becomes reality in 2028, we will treat the first patient. Just to mention, for CEST, 240 million is required. You can say it's a lot, but everything is relative. I think it's too little to guarantee competitivity in Europe because it has pan-European dimension, and politically is accepted that our region needs economical help. We are having pan-European flag, and we hope to absorb support from EU structural cohesion funds, other funds, of course, some contribution from the member states. And last but not least, we are also building the green concept for our project, and this will be the first green particle cancer therapy research infrastructure in the world ever. And this is my last slide. Thank you very much. And I can see that the research infrastructure based in a region plagued by conflict can develop cross-border relations, provide a common language to scientists from different regions. So thank you very much.
Thank you very much, Sanja. Very exciting and great to see as well the direct impact on the society here, where people can relate to. So let's move to another fascinating field, the astronomy. It's my pleasure to introduce to you our last panelist, Professor Xavier Barcons, who is Director General of European Southern Observatory, ESO, which is the world-leading organization in ground-based astronomy, which was built based on CERN convention, but it's a little bit different governance. So Professor Barcons is a renowned astronomer. He has been leading missions of European Space Agency. He's a member of Space Science Advisory Committee and many others. And he's advising on astronomy matters, Spanish Ministry of Education and Science as well. So dear Xavier, please, could you tell us how ESO fosters international cooperation and science diplomacy in astronomy field, the history, commonalities and differences with the CERN model?
Yes, thank you, with pleasure. Let me show you a few slides. I hope this works this time. So this is about the European Southern Observatory. Indeed, we're an intergovernmental organization founded in 1962, based essentially on the same convention as CERN was constituted. In fact, the first people from ESO were sitting at CERN until they moved then to northern Germany and finally to Bavaria near Munich, which is where we have our headquarters today. Our mission from the early days was to build and operate world-class astronomical telescopes in the ground, and also to foster collaboration in astronomy across our member states and beyond. These joint ventures started with 5 member states, all in Europe. Today, there's 16 member states, most of them inside the European Union, not all of them. And we also have a partnership with Australia and a long-standing relationship with Chile, where we have our telescopes since 1963. All the numbers give you the size of the organization. We have about 30 nationalities among the 750 staff members, Germans, Chileans, French, Brits, also from Israel, from the US, from everywhere in the world, actually. So this is the map of our member states. As you can see, it's very well centered in West Europe, but we have a very special relationship with Chile in South America, and the growing partnership with Australia, plus a joint venture that I will speak about in a minute with North America, with the United States, Canada, and also East Asia, Japan, South Korea, and Taiwan. Okay, so as I said, we have been building and operating very big telescopes from the very beginning, from almost 60 years now. First observatory to be established, it's in La Silla. This is in the Atacama Desert in Chile. We have relatively small size telescopes in there for today's standards, still very productive. The most powerful optical infrared observatory in the world. This is in Paranal, a bit more northern in Chile. That's where we have the very large telescope and its interferometer, plus another set of facilities in there. More recently, we've built together with our international partners this gigantic sub-millimeter radio telescope at 5,000 meters altitude in the Andes, which is called ALMA, Atacama Large Millimeter Array. And last but not least, we're now very busy building the biggest eye on the sky, the ELT, Extremely Large Telescope. Sorry, we're running now out of names with our projects. That will be a 40-meter diameter optical telescope, really a giant, very, very powerful, with no competitors around the world. And at the same time, we're also going to host the southern array of the Cherenkov Telescope Array, which is a gamma ray, very high energy gamma ray facility that it's being erected in our territory in Chile. So this is the portfolio of our facilities. We serve a broad scientific community with those telescopes. thousands of scientists in Europe, in Chile, and elsewhere in the world. That's our main goal in this life, to enable scientific discoveries, understanding how the universe works, how galaxies are formed. We discovered dark matter together with other observatories. CERN are trying to identify and tell us what it is, dark matter. I think we would be very happy if they could do this. That's really one of the biggest challenges today. But at the same time, we're also doing a lot of other very important things which come with a lot of societal benefits. For example, we're training next generation of astronomers and engineers through our programs. We're pushing frontiers of technology. We've made some very important technological discoveries that have then found applications elsewhere, including lasers, adaptive optics, and many others. We make our big contribution to education and science outreach. There's no astronomy book today that doesn't contain a number of ESO images. And we also have our very active role in international collaboration and in science policy. And I'm going to talk about this in the next minute or two. So this slide summarizes very much what is our science diplomacy approach. We're benefiting from the fact that we're an intergovernmental treaty organization, so we can plan and build challenging facilities, making sure that we will get the financing for it because of the commitments of our member states. That stability is really critical for our plans, and this is what enabled us to build these big telescopes. There's an additional very important benefit, which is that we can really get hold of the best of our member states' talents, and not only on people, but also on technologies and key knowledge that resides in the member states. That's critical for the development of our facilities as well. The core of the way ESO works is that we have all the member states rallying behind the same joint agenda. So it takes us a lot of time to get started with our big projects. We need to do a lot of convincing, but once we've got started, things flow very, very well. So when we compare ourselves with our colleagues in the US, for example, in the US, projects are started in an easier way. We have to invest a lot of effort on that phase, but then we have, thanks to this long-term planning, we have all the resources available for us. We have another golden rule at ESO, which is that we don't give anything for granted to our member states. They have to compete for everything, for contracts, for observing time, for personnel, etc. And there's a golden rule there, which is that the more you invest, the more you get back. So if you have a good scientific capacity, you will get a lot of observing time. If you have a good industrial tissue, you will get lots of contracts. If you don't bother about these things, then you only pay. And that has been working very well with our member states, just to be very blunt. We have chosen to retain European focus for the time being, but as I mentioned a minute ago, we have also made big strides beyond the European borders with this gigantic project, which is called ALMA, Atacama Large Submillimeter Array. This is a 1.3 billion project that was constructed for about 20 years and started operations in about a decade ago. This is a global partnership. We're not an organization. This is just a partnership lying on a trilateral agreement between ESO, representing Europe, between the National Science Foundation in the US and the National Institutes for Natural Sciences in Japan. And there's a few more partners around us in there. And in total, there's about 21 countries involved from 3 different continents and operating in South America at 5,000 meters altitude. This is really a very important venture, and I hope that this model can be exported to other facilities. So this is my last slide, just summarizing how I see our contributions to science policy. We were among the ones that pioneered open data. This is now very popular in other fields of knowledge. We have been running archives, science archives for decades, which are available to all the scientists in the world. We've set up standards together with the European Space Agency, which are now broadly adopted. We are also leading by example in ethical review processes in science for grants, but also for allocation of observing time. We were working together with the United Nations Committee for Peaceful Uses of Outer Space. There's a lot of concern these days about these mega constellations that are pretending to serve fast internet to the world, but indeed they are also polluting the sky in a number of ways. Dark skies, those are essential for our observations, for our science. We are working together with the governments and triggering tools and laws for this. We're also working with the European Space Agency on other projects like observation of space debris and protecting the Earth. And last but not least, I also want to mention that we're part of a joint club of European intergovernmental and international organizations dedicated to science, which is called Aeroforum, where we share experiences and best practices on how to run these organizations for the benefit of mankind. So I think this was my last slide. Thank you very much.
Thank you so much, Xavier. Great.
Sharing.
So you can see there are maybe two aspects where the presented organizations differ from the classical type of governance which society today is usually confronted with. So the first one is neutrality. If scientists should work together efficiently, they must be free from political agenda and emotions related to it. And it is difficult to come to the common understanding when you are driven by political or big industries' interests. So in this sense, CERN is really neutral, what is not completely the case of some other organizations. And the second difference is that the short-term individual interests are replaced by the long-term common interests. And I think this is also the role of science diplomacy, to include the future in our present decisions, which should be evidence-based, and to bring about the long-range investments, even though they would bring a return only for the next generation. So my question to all our panelists would be like focusing to these two aspects, neutrality and long-term investments importance. Could you please describe the most difficult challenges in building your collaborations, lessons learned, and maybe you share some interesting and funny stories with us? Maybe we can start by insights of Archana, please.
Well, I think you summarized it very nicely, Barbara. The main challenges come from resources, like Chris has also highlighted, particularly from countries that are middle-income economies and low-income economies. They really have a tough time to come on the center stage. So that, we have non-member states, we have observer states, we have associate member states, and then there are the member states. So to bring everyone on board in the same spirit, I think there are still challenges where we have to hold hands. And of course, when the scientific goals are clearly articulated and the deliverables are clearly articulated, this becomes slightly easier, I would say. So having myself driven a project for last 15 years, I encountered these kind of difficulties. But since we have a very good monitoring services, we have very good review services, and we also have a structure which is very transparent. So people see, and other institutions, they lead by examples. For example, there is a non-member state that comes on board, and then they are very successful. For example, they manage industrial contracts, they manage PhD students, they manage infrastructure back at home for capacity building. And some countries, some institutions, they do this very well, which is encouraging for the others to somehow emulate what has been done before. So I would say, yes, there are challenges, of course, like in every project, but definitely there's a lot of support structure and governance related mechanisms in place which help this. Thank you.
Thank you. So Chris, maybe you could expand on lessons from Sesame, which you already mentioned, and compare and contrast them with those from CERN, ITER, and JET, and other bodies, which you know very well, please.
So first, the long-term thinking and the fact that we're there by an international agreement is absolutely vital, as Xavier said. I mean, in the case of CERN, the Large Hadron Collider was approved in 1994, but we were planning it since the middle 70s, actually, when the previous accelerator was built. I can remember arguing vigorously, make sure we make the tunnel big enough so we can put something else in it later. We're investing in real infrastructure, let's keep using it. And that's been absolutely vital. Getting the Large Hadron Collider approved was very, very difficult. I was Director General and I put the proposal together. But once it was approved, we had some sort of certainty. And as I said, that's very different in the United States. And dealing with the United States, they're by far the most difficult partner we've had, actually, because they will only sign agreements subject to the annual availability of funding. And in fact, they've kept them, but you've got to have, the trust is very important there. Now, I would like to say something about the politics. Now, you said we're keeping politics out of these things. That's never totally possible, and of course not in Sesame. So first of all, I was very pleased to hear what Xavier said about no jus retour and so on. But in most of the organizations at CERN, there's no rule of jus retour, but there is terrific pressure to get the contracts going to different countries, to put it mildly. And there's pressure in making the senior appointments politically right. So it's not absent. The politics are there. And the place where politics is really present, probably not with ESO because the Atacama Desert, that was obvious, is in choosing the sites. I've been involved in the site choices of 3 big projects, 4 actually, and the scientists say we can choose the site on technical grounds. It's never the case. And let me give you just one example, JET, the Joint European Torus. There were many countries said we'd like to host it. They got down to, this was in the middle 70s, a short list of 2 countries, Germany and the UK. And there was a complete standoff for 2 years, absolutely nothing happened. And the way that was resolved was in 1977, a German airliner was hijacked in Mogadishu, and a lot of tourists were taken hostage. And the Germans turned to the British SAS, who had more experience of dealing with these things, said, could you lend us stun grenades and equipment and give us some training? So we did. And the hostages were freed with no fatalities, luckily. And afterwards, the German Chancellor Helmut Schmidt came to the UK to thank our Prime Minister, Jim Callahan. And he said, thanks very much. What can we do in return? And somebody nudged Callahan and said, JET, JET. He said, yes, you can agree to have JET in the UK. And Schmidt said, done. So things totally in different fields get into the balance in these things and can tip the difference. Similar things happen with CERN 2, which luckily was put at CERN, and I can tell you, ITER was caught up in the run-up to the Iraq War in a big way. I was very much involved in that, and a personal battle between Chirac and George W. Bush. Now in Sesame, just on the politics, of course we try to avoid politics, but when you've seen the list of members, it's quite difficult. When we meet at the non-political level, we can sort of do it, but we met in Cairo, for example. I was chairing the session, and we woke up in the morning and on the TV it said that the Turks had sent a boat to Gaza taking humanitarian aid, and Israeli commandos had landed on it. And some people were killed. We have a very, very tense meeting when that happened. And people saying we should discuss this, we should condemn what has happened, you can't do that, we're non-political. I mean, it all calmed down a few hours later, but it was very, very difficult indeed. There's been long-standing tension over what Palestine would be called. For a very long time, Israelis said, you can't refer to Palestine. You can't talk about member states. We don't recognize Palestine as a state. And actually, the official member is the Palestinian Authority. A couple of years ago, the Israelis backed off, and we can now refer to Palestine as a state, but minor things which would not occur to scientists can become very important in these matters. If you get beyond the scientific level, then it gets difficult. But when it became clear that we'd need special capital contributions to get Sesame finished, I invited all members who were prepared to put up $5 million beyond their usual contributions to a meeting. This was during the Arab Spring. And the Egyptians said, yes, we think that's a good idea, we'll come. And the minister was a very keen supporter of Sesame. But the day before that, there was a change of government, which was happening every few months in the Middle East at that stage. They never came and they didn't contribute. But who did come were Iran, Israel, Jordan, and Turkey. And I can tell you, chairing a meeting in a small room with about 10 people present, 2 of them ministers, one from Israel and one from Iran, is quite difficult. And the tensions were quite high, but we reached agreement and everybody said they'd pay. But Iran couldn't pay because of sanctions. I know more about sanctions than you'd like to know in a lifetime. They still haven't paid today, and they have a huge debt. They can't pay their regular contributions. So it's very difficult. And other things intrude. 2 Iranian scientists who are associated with Sesame, one actually extremely tenuously. He just showed up with a minister at the opening ceremony of the building. 2 of them were assassinated. And of course, out on there in the blogosphere, you could find things saying this is because they were involved in this project, blah, blah, blah. Completely untrue, I think, but it's been very, very difficult. So it's not all easy sailing, but on the other hand, that's what makes it worthwhile, that we can get through these things.
Wow, so thank you very much. These real life stories are so eye-opening and very useful to hear. Thank you for sharing this. Sanja, I'm sure you have also a lot of things to share.
Yes, I must say I really enjoy on all these comments from Chris. But let's say my life experience is, if we want to have science diplomacy efficient, we need to train diplomats in science. But the other side is very important. We need also scientists to enter politics. And I must say, what I can see, what was success for CEST is that there was a need for a leader who can approach all high-level politicians and diplomats, but leader who can use neutral language of science. And as you all know, it's not very common in the world that a scientist becomes Minister of Science. We have a number of cases, but let's say, I think in my case, what really helped is that I was a scientist who worked for nearly 20 years at CERN and really knew what international cooperation really means. And I can tell you something, my action was such, I need to act in 3 directions. One direction, I needed to get support from the local politics in the region. Then I needed to get support and trust from European Commission that we really can do it, because there was always doubts on our region whether we have really capacity or not. And third, I need also to get support from the scientists, from renowned institutions to help us to build capacity. And in discussing with scientists was easy, but I can tell you in discussion, I think the success was in discussion with politicians because I confused them. If politician meets politician, I was really using neutral language, a language of science. And one example I can tell you, in May 2017, when for the first time I met Commissioner Carlos Moedas, I came to his office with one slide. I said, we want that. And I can imagine how he looked at me. But 3 years later, we managed to try to put CEST on the S3 roadmap. So as I said, we really need more scientists to go into the politics, and we need to merge the 2 types of words, diplomats and scientists. Another point, since you Barbora mentioned emotion, I have nothing against the gentleman, but I want to say what was also contributed to success to steer the project CEST, I think it was emotion, actually. And you see, if you have a woman leader, it looks different from men leader, because I don't want to say that men don't have emotion, but women have different way to express this emotion. And I can tell you also, I think that was also a way that I radiate the patient and emotion, and that helped to come to the progress at this stage. So.
Yeah, thank you so much, Sanja. Indeed, I fully agree with you that passion and expertise in science, it's really what is needed. And thank you for this. We will touch upon that also a little bit later. But now I just would like to hear from Xavier, if you can also expand from the lessons of building ESO, and maybe not only ESO, but also these global partnerships, which are based only on Memorandum of Understanding, which you have great experiences with.
Yeah, well, I don't think I have much to add. I would, yeah, I was fascinated by the anecdotes of Chris, but also I would like to pick up on something that Sanja said, which is so important, which is trust. This is a key word. I mean, this is all about building trust. You have to build trust with the governments of the member states, with the societies in there, and this is the basis of everything. And yeah, indeed, you know, you have to speak the same language. You need to have a good gender balance in your initiatives, and you need to connect, right? This is so essential, and sometimes it's, you know, it's not written in any book of science diplomacy. What I believe, and this is maybe a little bit a slight criticism to the way these things are going now, the societal benefits of the large research infrastructures, which we all understand and we all think they are so important, I think they are becoming too much of a showstopper now, or of a required exercise before we can launch anything. I mean, all this is science driven. All these experiments, all these facilities should continue being science driven. Of course, it's clear that governments will only support if they see opportunities for development, for capacity building, for industrial contracts, for everything. But we shouldn't miss the point that this is all about delivering science. And sometimes I see this a little bit compromised. And yeah, maybe the last comment I wanted to make is about these international joint ventures with other so different agencies, like, for example, the National Science Foundation or others. I mean, Chris said that, yes, I mean, all these agreements are based on yearly appropriation by the United States Congress. That's clear. But again, let me go back to the trust. I mean, the partners that we are that we built and we're operating ALBA, we trust each other, and we know that we're going to face difficulties one day. So far, we've managed to build the thing in 20 years. We've been managing to operate it for another 10 years, and okay, I think this is a good starting point, and I trust that we will continue like this for another 20 years at least.
Yeah, great, exactly. I completely agree. And also on the point which you did, that the science, the point that science is in the center, is very important. And therefore, the communication about it is also important, and the connection of these two worlds. So in the process of science diplomacy, or breaking silos between communities, let's say, it's very important to address the strategic role of this good communication, right? And now I mean not only form or language, but also content. And the language of scientists and non-scientists, it's not the same, and it's not efficient to suppose that everybody understands what you are talking about because you understand it. Scientists must make efforts in educating public with the language which is adapted to the lay audience. And the same goes for the content, because sometimes it's more important than communicating the results is even the conveying the scientific method, the way how science works, or what does it really mean if something has been scientifically proven. So first of all, if we have enough data, we have seen a lot of issues with this during pandemic. And then also that result must be proven by another group or experiment if it should be declared as valid, which was the case also of Higgs boson, for example, discovery, where it was proven by 2 different experiments at CERN. And this is also the case for Nobel Prize. Yeah, for Nobel Prize winners. But anyway, it's still also important to communicate the positive impact on science on society, so that people also see the omnipresence of science in their lives. So I would like to comment our panelists on this aspect of communication. And first I would turn to Chris, because somehow it's another thing where my work is connected with his past actions, and therefore I know that nearly 25 years ago, as CERN's then Director General, he initiated the creation of International Particle Physics Outreach Group, or IPOC, which is a global network of scientists which are active in popularization of particle physics and related sciences globally, and to all kinds of audiences. And back then, Chris stated that the particle physics community has a moral obligation to inform the public on its activities, and also that informing school children is a good long-range investment. And thanks to all this, so I had a privilege to serve as a strategic development lead of this international collaboration now today for 7 years. And I am really happy to see that it is becoming more and more clear to all different stakeholders that reaching out to public and informally educating society by scientists is something of strategic importance if we want to build trust between communities, establish understanding of scientific process, instill appreciation for fundamental research, or convey the importance of evidence-based decision-making or reasoning, and also to train a new generation of specialists, which we need in order to create new technologies. And then we need also well-informed citizens, including decision makers. So in IPOC, for example, we are trying to do our bit through particle physics, but I think that it's it's of a general importance for any science. So I would like to you comment on this, please, Chris.
Yes, well, I do agree with you. We have a duty to share the excitement of what we're doing with the public. The public is paying for it, after all. So, and the public is interested. That's one of the main things. And that's why I set up that group at CERN, because the UK was doing quite well, relatively well, in informing the public through TV, public lectures, newspaper articles, and so on. And some of the countries were doing better than others, and I thought we should share experience. We also have, and it's also very important, as you said, this is one of the things that attracts young people to science and technology. We don't want everybody to become astronomers or high energy physicists, but they become scientists and then they go off and they work in whatever it is, in semiconductors or in industry or whatever. So that's really important. We also have a duty to warn the public and policymakers about the risks of climate change, loss of biodiversity, and so on, and pandemics. And in fact, the scientists were warning about the dangers of pandemics, but the warnings weren't taken seriously enough. That's difficult because you've got to balance being accurate with being clear, and they can be in conflict. And the big barrier is the lack of understanding of risk and statistics. And one of the big challenges is conveying the idea of uncertainty in what you're doing, in what we're doing. So to give an example, I've seen a clip of Donald Trump saying there's quite obviously a link between the measles, mumps, and rubella vaccination and autism. It must be true. I saw a child who just had the vaccination and 3 weeks later he turned out to be autistic. Now, what can you do with that? You can patiently explain that correlation is not the same thing as causation, and you can put the statistics under people's noses. But people, Donald Trump anyway, didn't want to listen, apparently. It's very, very difficult to deal with these things, and we have to think very carefully about the words we choose. So, for example, we use the word error. We say, oh, this was the error. And the scientists say, oh, there are errors. They don't know what they're doing, probably all wrong. So you have to talk about within the margin of uncertainty, saying we're doing the best we can, but we can't be exact. And so you have to be very, very carefully about using the words that you use, and it has to be judged to the audience. There's no general principle for how to do this. You have to decide how to do it. There's also danger of scaring people. I mean, one of the things we should be doing with these global dangers is educating young people. But I'll give you a very personal example. One of my youngest granddaughter, who is 13, has become a vegetarian. So I said to her, oh, that's for ethical reasons, is it? And she said, no, it's because I'm worried about climate change. I know that meat eating, raising a lot of cattle uses a lot of energy. So that's rather good that she knew that. And in fact, I think she's the only person I know personally who's become a vegetarian for climate reasons. So I'm quite proud of that. But on the other hand, she's a very nervous child, and she's become pretty nervous she worries a lot about climate change. That's not so good. So there's a very delicate line here between not appearing to be fanatics. I mean, you know, I am fanatical about the need to do something about climate change, but if I appear to the public fanatical, oh, this guy's got a nut, I needn't listen to him. So we have to get over the seriousness without somehow overdoing it. So these things are very difficult. So communication with the public and policymakers is very important, but it's absolutely not straightforward.
Yeah. Yeah, I completely agree. This would be a great subject for another panel. We could talk about it a lot. It's a big challenge. So, Sanja, I know that you also have been promoting also outreach in your position of science minister.
Yeah. So let me say, when we do science, we always do that for society, and it's always sometimes it's not easy to explain our results, why they are important for society, like for example, discovery of Higgs boson. But in connection with SEAS is much easier because we are fighting cancer. And this is a big challenges, and we did not have a problem really to come to the citizens and explain why SEAS is so important. On the other hand, why outreach is so important, in particular of our region. I mentioned for 60 years, we did not have any research infrastructure based on new technology. So we are missing something in our region, which is like self-organization of user community. And this is missing. This is very different from developed countries like Western Europe. And so if you talk about SEAS, and I mentioned it is going to start maybe to work in 2028, our young generation are going to be user. And for us, the outreach capacity building is really so important. And let me also emphasize how I'm grateful for existence of IPOC, because recently, a month ago, we organized masterclass on the topic of importance of particle therapy for cancer, treatment of cancer. And believe or not, we attracted more than 1,000 students participate in that event. And let me also say why this big research infrastructure is so important, like what I mentioned, SEAS. I said this is research infrastructure which is going to be in the region of Southeast Europe, but it is going to be open research infrastructure. So our main task is science excellence. And so when opening this masterclass, there were participation from students all over the world. And so this is something very beautiful, and we need to go into that direction. And this is our main task, and we are really doing a lot. And I again thank for existence of IPOC, because most of the countries from Southeast Europe are member of it. So your microphone is switched off, Barbora.
Sorry, I had to unmute. Yes, this is great to hear. It's really important to train the young generation and also to make sure that they are interested ambassadors of science, even if they are not going to all become scientists, of course. So let's move on. I think as already Sanja has mentioned a while ago, so I fully agree. If we want to have science diplomacy really impactful, so there is two groups of science diplomats which must really work together: politicians and diplomats who become science diplomats, and scientists who become science diplomats. And only if these two groups of science diplomats work together from both silo communities, so they act like receptors with open mind, and they would enable opening up and connecting of the two silo groups. This is the only way how science diplomacy can reach its full potential, and the solid bridge could be built. And I have also realized that there are several definitions of science diplomacy. Maybe it's different for scientists than for diplomats, I don't know. But it would be interesting to hear from our scientists in our panel, what do they think about that? And for example, for me, it's really something which is about building bridges between not only scientists and diplomats, but scientists and society as large, and reaching to young generation, because they are future leaders and decision makers. So all the players in society are important there. And like that, science diplomacy is a vehicle for informed and evidence-based decision making and sustainable leadership. So what do you think about science diplomacy, your definition, Xavier, please?
Well, I don't have a definition. I'm not a theorist of any of this. What I think is that this is a tool to connect science and society, and this is so important, and that was being underlined now in the context of outreach, for example, which is of course a duty for us, but also a tool to connect with society in all its aspects. We need to engage with society. We need to train the people to be able to take advantage of the science that we produce. we need to work also on the sustainability aspects of science, and not just environmental sustainability, but social sustainability and economic sustainability. All these aspects, in my view, are also part of science diplomacy, because they become vital for the existence and for the business that we do in developing science facilities and in conducting science research. So it is precisely the need to ensure this connection with society, where we need the help from this sort of discipline that we call science diplomacy, where we try to bring together scientists and diplomats and find common ground there. But for me, the ultimate goal is precisely to secure the links with society. That should be the ultimate goal of all this discipline.
Right, exactly. Would you like to add something also on communication and outreach? Because I know that you are also active in this field.
Yeah.
Everything was said.
I think very much everything has been said. Yeah, I mean, as I say, we spend quite a lot of effort on this, but it's well invested, and yes, that's always the case. Yeah, thanks.
Yeah, absolutely. Archana, would you like to comment also on outreach, or can you put it together with your answer on science diplomacy, please?
Thank you, Barbara. I think Xavier has very nicely linked it to society, and whatever we do, I think scientists, even though they are following their passions, looking at answers to their curious questions, it has to, in the end of the day, be related to national priorities and also international priorities. So I think SDG goals are really a good lens for us to look at from whatever science that we do, whatever collaborations we build, whether it's national or international. If we look at the delivery, what we are giving back to the countries and to the world in general is what mega science is about. And science diplomacy must play a big role, because like Chris said, we cannot turn a blind eye to politics. So we absolutely need the diplomacy in the diplomats and the science as well to come alongside together. And certainly people like Sanja are, glowing examples of scientists becoming politicians, who then also carry the message that it is possible. Because people don't take you seriously, if sometimes you go and, speak about your projects and so on, but to be taken seriously, it needs a large body of work behind. And I think, like you said, the CERN model of science diplomacy is really something like a leading light for others to follow, which is happening already. And I hope this also goes to parts of the world where this is more needed in terms of the SDGs and the deliverables from the SDGs. Thank you.
Yeah, great, exactly. Thank you very much for this. So I will follow up exactly on what you said now, that before I ask the definition of Sanja also for science diplomacy, that I profit also from the fact that she is a former science minister, what is quite unique for a scientist and for a lady. So I would like her to share the story, how that happened actually, because I think it's really important that what we all agree here, I see when we are talking, that the scientists, to have scientists in such important positions or diplomatic positions, and also women. And so today it's probably, I think, less straightforward for scientists to become a science diplomat or politician than for diplomats to become science diplomat, because the mechanism of career transition are not very clear. But of course, one can do something, some difference also without mandate, but it's not so easy. I remember that when I started the economic collaboration and innovation diplomacy of my country with CERN, I had only my vision, enthusiasm, and proactivity. And it was not that easy. It was going, but when I got my proper mandates from government, things changed a lot. So I would like you to comment, Sanja, please, on the fact that it's really important that more scientists are given the official positions, like Archana also said that this is
Yeah, thanks, Barbora. If you ask me how I became Minister of Science, I would say by chance. Actually, our government wanted to include more experts and not only politicians. And also they want to increase the number of women in the government. Although I was 20 years outside of my country, when I was invited to become minister, I was still connected to my country because, as I mentioned, all this civil war in 2006, Montenegro became independent country, and we needed to renew all contracts, cooperation agreements, including with UN, but also with CERN. And I played that role. I was like bridging Montenegro to CERN, and I was also helping so much young people and teachers to get in connection to CERN. I would say like that. But to add your point is all success, big success in SAIST happened exactly because we merge communities, we merge politicians and diplomats together with scientists. And there were very nice 2 events which we organized. After the first event, which we organized 2018 at ICTP Institute in Trieste, where we had this community, mixed community, we got financial support, first financial support from European Commission. And then we had another great event with 150 participants, politicians, diplomats, scientists, adjusting language to everybody. And after that, Nicole can confirm, 2019, we got support from the Federal Department of Foreign Affairs. And I must say, we need to merge these 2 communities if we want success of science diplomacy. And my definition is like, I would say it's the most powerful instrument to foster broad collaboration and help solving global challenges. This is for me kind of definition of science diplomacy. Thanks.
Great, thank you very much, Sanja. So I must say that your government at that time was very visionary, and it's maybe a good inspiration for others. So thank you very much. I think that at the end, we know that what we call here CERN model, so it works. It works among scientists, it works among particle physicists, high energy physics, astronomy, also microbiology. There is another organization like that, IMBL. And therefore, it's not surprising that it has evoked several calls for similar multinational research efforts in other fields. Like, for example, call for CERN for oceans, or CERN for genomics, or agricultural science, or human brain research, or, you know, which have been published. And we could go further with ideas. And for the moment, it has not yet been fully explored. And yet there are really many areas where well-informed decision-making and sustainable leadership, global collaboration is needed more than ever. And the idea of doing this was already once officially proposed in 2015 at the conference called CERN Model for UN Global Goods and Addressing Global Challenges. And this conference was organized when CERN was led by Director General Rolf Hoyer, and the meeting took place in Palais des Nations in Geneva, aiming to stimulate more creative approaches and partnerships in addressing today's challenges, and to help strengthening the provision of global goods in rapidly changing international context. So somehow the proposal was not followed up by the stakeholders at that time, perhaps because back in 2015, its importance and potential has not yet been fully understood as some urgent solution. However, today, we are at a different stage of awareness and acceptance that science, politics, and society must work together, and also general recognition and importance of science diplomacy has been accelerated in the few past years. So we can take, I think, advantage of pandemics and everything what has been happening, and think about the lessons learned and how we could put a long-term vision and short-term plans at least on the same footing and unite for these common interests of the global interconnecting humanity. And I would like to ask the panelists whether you think that it could be a good moment at this stage to reopen this discussion from 2015, and do you think that the CERN model can potentially be used also for successful policy making in different areas and maybe potential path towards sustainable development? I let you, who would like to reply the first?
I'm happy to try to reply if you like.
Please, yes.
I think we have to be careful. There are some limits to the CERN model. And let's ask when it works, why it works, other contexts. So if we think about science helping to solve global challenges, which is what you've just been discussing, Let's look at an example where it worked, and that was with the hole in the ozone layer. There was very quickly, when scientists put it on the agenda, there was an agreement. The whatever they are were banned, and it's closing. But if we thought, can we do that about climate change, for example? Well, we have an international agreement, but it doesn't have any binding force, and we're not really collaborating on the technologies. So let's look at the differences. The thing is, with the ozone hole, the problem was very, very clear. The danger's clear. The solution was cheap. And what's more, there were no losers. Now, when you come to climate change or tackling climate change or avoiding climate change, it's harder. One of the big issues is how you reduce emissions while fostering an economic growth in India and Africa. That's absolutely non-trivial. And there can be losers in this. I mean, we can't say to countries, you can't develop because you'll spoil the climate. So that's not easy at all. And if you try to collaborate on the technologies, there are various places we could try. For example, carbon capture and storage. It can be applied in very many different ways, in making steel, in making power, in making cement, and there are different technologies. And at the G7 summit in 2003, there was an agreement to try to collaborate so we'd share information about trying different things, but it never happened. And it didn't happen because people didn't fund it. There are intellectual property right issues and so on. Another area would be small modular reactors. Small modular reactors may be cheaper than big reactors, but we need to build many of them of the same type, and we'd like to build examples of several of them of different types. That's not happening, and the reason is because people worry about proliferation, there's security issues, again, there's intellectual property issues. So the CERN model is very good for abstract things, but it's much harder when it comes to real things. I think it's also important to ask, when does the CERN model work and when doesn't it? Now, in the case of CERN, when CERN was founded, if this was before the era of cheap international travel, the only way in Europe that if you wanted to do accelerator-based physics was to build the big European accelerator. The countries individually couldn't afford to compete with the United States. So CERN had to work. The people who are in the field, their careers depended on it. Now, to a certain extent, that's true with something like ESA. If you want to work on the southern heavens, you've got to have an observatory in the Southern Hemisphere. But other things are not the same. EASA, for example, there's no real particular need. It was driven top down. It hasn't had a big impact. So you've got to ask, where are the places these organizations are really needed and that can have a big impact? And unfortunately, it's not so easy. It may be possible, I may be wrong, but to see them in tackling these big problems, it's not so easy. But some of them, it may be possible. For example, the idea of a CERN for climate modeling, which needs a lot more computing, was trialed by my colleague Tim Palmer in the CERN Courier, the latest edition. I've been discussing that with Tim for 10 years, actually. So there are areas that could work, but don't think it's a solution to all problems.
Yeah, absolutely. Maybe it's not really that we wanted CERN or to say that CERN for everything, CERN for SDGs, but the idea that there is global collaboration and the spirit. It's not about the model as details of the model, but what matters, it would be the spirit of a global partnership, global interests beyond as much as possible national limitations in terms of legal frameworks and political agenda. As much as possible, I say, all the example which we have seen when it worked. So from this point of view, if maybe some of the other panelists would like to also comment on that, what do they think?
Yeah, so I would really just follow up on what Chris said. Indeed, it is not a panacea for all difficulties of the world. However, since it has been very successful, sometimes we have to look at the gaps in the readiness to accept the model as well. So we need first to prepare the grounds, and like Sanja mentioned, that you have to work very hard to drive the mission of what is it you want to do. And many a time people are not ready to understand what exactly are you trying to do. I'll give you an example that, Sanja, you know, I'm also trying for something what you have done in this part of the world, in my part of the world, you know. And when I speak to other people, they say, this is probably 20 years down the line. So people are not ready. And even though there are examples in Europe, examples in the United States and so on, but we do need to prepare this ground. And that's where science diplomacy is going to be extremely important to bridge these gaps. Not only, I will not say of understanding, but it's just the historical development of the world and, you know, the cultural differences, the acceptance of change, and of course, whatever scientific evidence you can bring, until, you know, it's in the face, until then you can't really shake old beliefs. So the CERN model is fantastic. I speak to my own colleagues who work at CERN from India, and I see that it's sometimes very difficult to match the pace at which change happens at CERN, and the change or acceptance of new ideas happens in other parts, in that part of the world. So definitely, I think the preparing the ground has to be made, and the CERN model, like you are doing right now, which is showcasing, look, here is a model that has worked for certain.
Did we lose you?
Certain
Archana?
issues. Can you hear me?
I don't know about the others. Can you hear her? Because I cannot.
I can hear.
Yes. So just wrapping up that, you know, CERN model is definitely a great model, a great partnership. We need to prepare grounds, and this is workshops like these are very important to at least heighten the awareness that there are other ways of solving difficult problems. Maybe not all, but many can be solved, like the climate crisis or the green energy, for example, as well as was mentioned by Chris too. So I definitely believe in the positivity of this CERN model, and I would definitely do all my best to take it forward as far as we can by means of these kind of workshops or interactions with politicians, with the scientific community in the various regions to bring more impact to society. Thank you.
Thank you very much, Archana. I was kicked out of the meeting for a while, so I have lost something what you said, but I fully agree that science diplomacy is exactly the tool which can bridge these gaps, and that there is still a dialogue needed, and we have a lot of work to be done ahead. So it's great to start talking about it now, and discussions will continue, I hope. Sanja?
So I just want to mention that I'm really happy about the UN agenda and well-defined 17 SDG goals, and also EU policy to go for the Green Deal. And I think this is our road. And somebody mentioned there is also 18 SDG goal, which is smart specialization strategy. And I believe that each part of the world can really contribute to getting our planet a better place for all. And my wish is to see more research infrastructure in the world, and because I think these are the most important instruments to cope and with all our challenges. Thanks.
Great. Thank you, Sanja. Maybe Xavier, would you like to comment on the usefulness of this CERN model, or the idea of it, please, or other areas?
Yes, sorry, I went away for a second. Yes, the point I will try to make is that what seems to be called the CERN model only works when it's fully understood, supported, and backed by politicians, by the political powers. If not, it will remain an example of something that worked well in some places, but it will not become the tool to tackle, for me, the biggest challenge that we have in front of us, which is sustainability in all its concepts. If this is felt as a necessity by the political powers, here is an example that may work. But if it's not felt as a necessity, it will remain an example. So that's how I see it. And let me just say one other word about sustainability, because this is, of course, something that we all care a lot about. Let's not forget that sustainability has not only the environmental component, it also has the social and the economic component, and they are very, very heavily interlinked, and we cannot address one without the other two. Thanks.
Can I please let me jump in here, Barbara? I want to thank you and your excellent colleagues for a fascinating journey and the importance of science diplomacy and the model that CERN is developing, will continue to develop clearly with leadership of those that are involved in the call today and others.